Okay, this calculus review is on derivatives. It's very straightforward. Just got to remember your derivative rules. It does get, a little complicated. Sometimes they'll ask for the second derivative. You've got to remember implicit differentiation. You've got to remember your logs and your exponents. So this is the part of the formula sheet. I think it's top back of your formula sheet that you need to be focused on. And this is what your formula sheet quiz is going to be the next time we have class. So this is where you need to focus, and this is what you need to make sure you have memorized, especially the chain rule and the logs and the exponentials and the trig. Okay, so we are going to start Barron's test number 1, or the test number 1, but we're going to start with number 7. No, we're not going to start with number 7. Sorry, we're going to start with number 3. Okay. So number 3 is, mine's kind of blurry, e to the negative x squared, and that's if y equals, and I want y double prime of 0. That means take the derivative, then take the derivative again, and then whatever you get, plug in a 0. Okay, so again, I hope you do this at your own pace. Feel free to watch it once and then go back and write, or watch it twice, or whatever you need to do so that this comes back to the front of your brain. Okay, so y prime is going to be, let's see, you leave it alone, and then you take the derivative of the up, and then it's times ln of the base, but ln of e is just 1, so we don't write that for this particular problem. Okay, now I can't really clean that up any, so now I've got to take the second derivative, and I'm going to use the product rule. So let's see, I'm going to leave it, then I'm going to take the derivative, then plus, and then I'm going to take the derivative, and then I'm going to leave it. So this is the original, the derivative of the up, and then this is that guy which we left alone. And you could clean it up, or you could just start plugging in a 0. E to the 0 times negative 2 plus e to the 0 times negative 2 times 0 times negative 2 times 0. Well, that goes to 0, that goes to 0. That's going to wipe all that out. E to the 0, anything to the 0 is 1. And 1 times negative 2 is negative 2. Okay, the next one we're going to do is number 5. But number 5 refers to this chart right here. We never did any like this, but it's crazy easy, and it has popped up a couple times on these practice tests. So we're going to do a couple of them together. You've got a couple of them for homework to make sure you're good. But this is just, this is f, like, let's see, this would be f of 1 equals 2. So f, when your x is 1, gives you 2. This is f prime of 1 would give you 1/2. So it's just a chart. You don't ever know what the original function was. And like I said, we're going to do number 5. So I want g of f of x. So that's a chain rule. Okay, and again, I don't know what the functions are, but it's derivative of the outside, leave the inside, times derivative of the inside. It's the turducken, to how we talked about it in class. So that's it. Now I want it at 3. So g prime of f of 3, f prime of 3. Now I'm going to use my chart. So I need f of 3 and I need f prime of 3. So I go back to my chart, and f of 3 is 2, and f prime of 3, nope, sorry, f of 2 is 4, and f prime of 3 is 2. God gracious. F of 3 is 4. F prime of 3 is 2. So I'm going to take that information and plug it back in here. F of 3, again, flip back and look at that chart. F of 3 is 4. So I want G prime of 4 times, all right, F prime of 3 is 2. Don't multiply your 2 and your 4. That's not a plain old 4. That's G prime of 4. So now I come back and I go G prime of 4, and I get a 1/2. So if that's 1/2, then that would be a 1. Crazy easy. You don't know the functions. You just have to know your derivative rules. Okay, that's it for Barron's 1. Now we're headed to Barron's 2, and we're going to start with number 3. Okay, number 3 is just a normal straight up derivative. It's just got this e to the ln of u stuff, and I just want to make sure that we remember those rules. All right, this is division, so you have to remember your division rules, and that's your low d high, high d low. So low, now I've got to go derivative of the high, so times e to the ln of u, that's the leave it part, and then the derivative of the up. So the derivative of this is 1 over u, then technically that's times the derivative of the of, but my of is a u and the derivative is 1. Please make sure you understand that. Okay, and then minus, so that's my low, there's my low, and there's my d high, and then minus high, and then d low over low low. And now I just have to clean this up. Well, the u times the 1 over u cancels and gives me a 1. So now I have e to the ln of u minus e to the ln of u over u squared. Well, these two things subtract on top and give me 0. They don't cancel and give me a 1. They subtract and give me 0. And 0 on top of anything is 0. Okay, now we're going to go to number 6. Okay, number 6 is a sine cubed, and it has some stuff in its of. So this is a full-on turducken. And some of you, I know when we did this, when you had trig, wrote your powers on the outside, and that's awesome. That's totally fine, because that cubed is the outermost function. So that's your turkey. Then the sine is your duck. And then the 1 minus 2x is your chicken. I think I got that in the right order. So first thing I'm going to do is a power rule on the outside. So 3, all this stays put. Knock my power down 1. Okay, that was the outside. Now I got to do the derivative of the inside. Well, the derivative of sine is cosine. Leave the inside, and then I got to do the derivative of the of, which is negative 2. So here's my there's the duck, and there's the chicken. The outer is the cubed, the inner is the sine, and the innermost is the of. So now I'm just going to clean. That's going to give me negative 6. And then I'm going to rewrite this 2. I'm going to put the power back on the sine. 1 minus 2x cosine. And I think that is D. So again, not difficult, just something you have to make sure you remember. Number 7. We're going to roll right into number 7. Number 7 looks to be a product rule. Got some e's in it, so I think that's why I wanted to point this one out. So this is my original problem. Okay, so here I go. I'm going to go derivative, leave it, plus, leave it. All right, and then the derivative is going to be the original times the derivative of the up. Okay, well the up is this, which is that, and the derivative of that, pull your power down and knock 1 off your power. So this being multiplied by that is going to cancel because that's an x squared on the bottom. So these are going to completely cancel. That negative right there is going to change that plus to a minus. And if I'm looking at my answers, it looks like they've GCF'd. They both have this e to the 1 over x. If I GCF that out of the first term, I've got a 2x. Remember that that minus is going to make that plus a minus. And I don't have anything left in that one. And that is B. So not only the derivative rules, but also the cleaning up. So just be careful there. Okay, the next one we're going to go to is number 36. There it is. Okay. So I have this function. Oh, sorry. And I want g prime of 1 so this, I don't know if you guys remember this, but this is the one. It was one of those things where it was so easy, it was really easy to forget. So g prime of x is going to equal f of 3x minus 1 and then times the times the derivative of that, which would be 3. And then if I plug in a 1, that'd be 3 minus 1 times 3, which would be 6. Three x minus 1. Yeah, take just a second and stare at that for a second. Okay, so I hope that kind of sunk in. Again, it was one of those things that was super easy and super quick and super easy to forget. So all I did was took my upper limit on my integral and plugged it in for my f, multiplied by the derivative of that. And then I want it at g prime of 1, so I plugged in a 1 for my x. So again, super easy, but super easy to forget. That was 36. All right, now we're headed to 40. And 40 is another one of those. It doesn't have a chart, but it does sort of give me basic information. All right, now the d squared over dx d2, that's the second derivative of f squared of x at x equals 3. Well, if I have f squared x, and you can think about that like this also. Okay, so if I'm supposed to take the derivative of the first derivative of this, then I'm going to do the power rule. Take 1 off my power, but this is a turduck. I have to take the derivative of the inside, so that would be that. Okay, that's the first derivative. It wants the second one. So now my 2 is a constant. I'm going to leave him outside. So now I'm going to go product rule on this guy. So I'm going to go derivative, leave it, plus, leave it, derivative. The derivative of a derivative is the second derivative. Okay, yeah, so derivative, leave it, derivative. And then I want to know all this stuff at 3, so I'm just going to start plugging in a 3 in here. Remember, you've got this 2 out front. Well, f prime of 3 is 5. F prime of 3 is 5. F of 3 is 2. And f double prime of 3 is negative 2. So 25 minus 4 is 21, and then times the 2 would be 42. All right, now we're going to head to Barron's 3, and we're going to start with number 3. Okay, holy cow. It wants the third derivative. All right, and it wants it evaluated at e. So here I go. I'm x ln of x. So this is a product rule. Okay, so here I go. Derivative, leave it, plus leave it. The derivative of ln of x is the derivative of the of over the of times ln of the base, ln of e, which is 1. So then that would be ln of x plus 1. Okay, so that's my first derivative. My second derivative is going to be the derivative of this, which is 1 over x, ln of e, which is 1, and then plus he's going to go to 0. Okay, so this is my first derivative. This is my second derivative, which is the same thing as that. So my third derivative, I'll pull that down, take 1 off your power, and then I'm supposed to shove an e in there. So negative 1 over e squared. There you go. There's 3. All right, now 23. Okay, 23. Here's my function, and I just want the first derivative, thank goodness. All right, ln. Now, you could go straight to your derivative if you want to, and if you kind of get tunnel vision, which I absolutely sometimes do, that's what you're going to do. You're going to do dov over of. You're going to do the derivative of the of over the of times natural log of the base, and it's going to be hideous. But if you can kind of keep your head up a little bit and think about your log properties, it can come in and make this problem so much easier. And I hope you guys remember doing that when we taught this. So I can make this, because it's division, ln of x minus, okay, this I can think of as a power to the 1/2, and powers get kicked out front. So now this is so much easier. All right, the derivative of ln of x is dov over of times natural log of the base, which is a 1, minus 1/2 is a constant, and then dov over of, again, times natural log of the base, which is a 1, and then I'm just going to clean a little bit. I'm going to let these 2's cancel because they're both single, not equals. Okay, and then we're going to look at my answers. Well, they have one fraction, so I need to get, but I can kind of see my x and my x squared plus 1. So I'm going to go common denominator. So that gives me x squared plus 1 minus x squared over x, and my x squareds are going to cancel and give me a 1. So we're that guy. So it was 23. All right, moving on to Princeton. We're looking at number 5. Okay, now this sucker has x's and y's in it, and I want dy dx. Okay, so this is called implicit. There we go. Implicit differentiation. Okay, now this is in with regards to x. So anytime you take the derivative of something with an x in it, you're fine. But if you don't, then you need the dy dx. Okay, so I have x squared minus 2xy plus 3y squared equals 8. And I'm just going to treat them all individually. So this one, 2x. It's all x's. That's easy. This one, I'm going to pull my minus 2 out. He's a constant, and leave him out here. And I'm going to go product rule on the xy. So I'm going to, let's see, leave it. Then the derivative of y is 1, but it's a y, so it's got to be dy dx. Plus, and then I'm going to take the derivative of the x, which is a 1 and doesn't need a dy dx because it's an x. And then my y, which I'm leaving. And then plus 6y, but it's a y, so then dy dx, and the derivative of 8 is 0. Okay, so now I have to solve for dy dx. So I'm going to now distribute my minus 2 back in. And again, I know I'm going to go fast, but I want you guys to like pause it and finish the problem and then check it against mine. Or watch me and then you do it. All right, I'm going to leave my dy dx's over here. And I'm going to move my 2x and move my 2y over to the other side. Then I'm going to GCF my dy dx. And then my very last step is going to be to divide by this thing. Now, that's not a choice. But gracious, there are a lot of 2's in here. So I'm going to, let's see. You can just let them all cheat with a 2. That would be fine. Or you can GCF a 2 and then cancel it. It doesn't matter. I'm just going to let everybody cheat with a 2, which is like GCFing a 2 and then letting it cancel. So negative x plus y over negative x plus 3y. Okay, I'm looking B and D. B is flipped D. D, y minus x, that's a positive y and a minus x, that's good. And a 3y minus x, 3y minus x, yep, he's good. Okay, so implicit differentiation. All right, now we're headed to number 10. Which is just, it's another trig. You just got the cosine squared. It's a double derivative, so you got to go twice, and you're evaluating at pi. Again, this isn't difficult. I just want to make sure you remember. And again, if some of you want to do this, you can, so you can see the outer function, the turkey. Okay, so the first derivative is going to be 2 cosine x to the 1, then times the derivative of the inside. The derivative of cosine is a negative sign. then technically the derivative of the of, but that's just going to be a 1, so I'm not even going to write it. And then I'm just going to clean that up. Okay. So that is my first derivative. My second derivative, I'm going to leave the negative 2 out, and I'm going to go product on that guy. Yep. So let's see. I'm going to have, I'm going to go derivative. So negative sign, leave it, plus leave it, derivative. So negative 2, negative sine squared x plus cosine squared x. Which is almost 1. Let's see. So now I got to plug in my pi. All right, think about pi. Sine is going to be 0. Cosine is going to be a negative 1, but it's going to get squared, so it's going to be a positive 1, so that's a 1. And then times this negative 2 is going to give me negative 2. So I hope we've done enough of the turduckins and the turducks that you kind of remember the chain rule. Okay, so that was number 10. Now we're headed to number 20. Number 20 is not difficult. It's just large. Yep. All right, that's the first derivative, thank goodness. And it's at 0. And this is just a ginormous product rule. Now, I'm going to think about this guy as all that crap to the 1/2. Okay? So here I go. I'm going to leave it. And then I'm going to take the derivative. Pull the 1/2 out. Leave the inside. Subtract 1 off the power, but then I have to take the derivative of the inside. Ooh. Plus. Oh, wait, hold on. That's a 3. God, mine's so fuzzy. I'm sorry. That's an x to the 3rd. Okay, so this would be 3x squared plus 5. Okay, my bad. And then derivative of the first one times the second one. And that's all to the 1/2. And I want this at 0. Well, I'm not cleaning this up. I'm just going to plug in a 0. He's going to go to 11. He's gone. He's going to be 121 on the bottom and square rooted. And then I still have this 1/2. All right, make sure you understand that. If this goes to 0, so I'm left with him, but he has that power, which is square root me and move me to the bottom. And then times this guy, which is a 5. Okay, and then plus. All right, this is all going to 1. That's all going to go away, and that's 121 to the positive 1/2, so that's an 11. So let's see, these 11s cancel, so that's 5 over 2 plus 11. It's 22 over 2, so 27 over 2. There you go. That was number 20. All right, we're headed to 26 and 28, and then we're done with this one. 26 and 28. And you could probably handle 26 on your own. Again, this is just another turducken. Write it so I can read it. All right, and we want f prime of pi. Okay, and again, if you want to do this, I would not put the cube right there because I don't want you to think that it's the of that's cubed, because it's not. It's the cosine that's cubed. So this is a full-on turducken. So I'm going to pull the 3 out and knock my power down by 1. Now I'm going to take the derivative of this guy, so that would be negative sine. Leave the of alone. And then I've got to multiply by the derivative of the of, which is just a 1. And I want pi, so 3 cosine squared pi plus 1 times, now that negative, I'm just going to kick him out there, sine of pi plus 1. Let's see, negative 3 cosine squared a. Yeah, there you go. 26, and then, okay, 28. And 28 is definitely a turducken, and it's a turducken with ln's. So I just want to make sure we're okay with this. So this is ln of 1 minus x. Okay, so the chain rule says, well, for logs, yeah, so if I start out here with my turkey, that is the derivative of the of, dov over of. So the derivative of the of over the of. Okay, so the derivative of the of would be negative 1 over 1 minus x over the of, and then if I Bojangles that, I get so again, not difficult, but these are the more difficult ones of these straightforward derivatives. And you're not going to see tons of super easy, very nice, beautiful, regular derivatives. You're going to see lots of trig and lots of turducks and turduckens. Okay, so now we're headed to Princeton 2, but we're going to number 26. Princeton test number 2, going all the way to number 26. Okay. It says find dy dx at x equals 1. So I'm going to take the derivative, and then I'm going to shove in a 1. All right, so this is a turduck. So first I'm going to do my power. Okay, there's the outside. There's your turkey. Now I got to do times the derivative of the inside, which is a high-de-low, low-de-high. So here we go. Starts low. Low, d-high, minus high, d-low. And again, I know I'm going fast. Feel free to pause it. Over low, low. And now I'm going to stop. I'm not going to clean this up. I'm going to plug in a 1. So let's see. 1 minus 2 over 2 minus 1 to the third. Plugging in a 1. 2 minus 1, 3. 1 minus 2, 10. 2 minus 1 squared. Okay. This would be negative 1 over 1 cubed. 2 minus 1 is 1. 1 times 3 is 3. 1 minus 2 is negative 1. So negative 10. So that's going to be a plus. And that's going to be a 1. That's going to be 4 times negative 1 times 13, which is a negative 52. Okay, now we're headed to 33. have a star by number 33. Let's see if we can figure out why. It says, find the values of dy dx. Ooh, and there's an s in parentheses implying that there could be more than one. Of that at y equals 1. Okay, so first of all, this is implicit differentiation because there are x's and y's all in my problem. So here we go. First, let's find the derivative. So I'm going to take the derivative, leave it, plus leave it, take the derivative, which would be 1, but then I need a dy dx because it's a y, plus take the derivative, and then dy dx, and then equals 0. And I'm gonna scoot this guy over to the other side. I'm gonna be left with these two, so that I'm gonna GCF my dy dx. So dy dx, I'm just trying to avoid writing this thing. So dy dx equals negative 2xy over x squared plus 2y. All right, now I know that y equals 1, but I don't know what x equals, so I can't plug in an x. And if I just have a y and I plug it in, I'm still going to have x's in here. So what I need is what x goes with this y. So if I come over here and say if y equals 1, come in here and let's find his x. So that would be x squared times 1 plus 1 equals 5. So x squared equals 4. So x equals plus or minus 2. So here we go. If you want to think about it like points, they gave me that y is 1, and for that 1, I got a 2 and a negative 2. So now what I have to do is I have to plug both these points into here, and that's where the s comes on the values. So I'm going to do this one first. So negative 2 times x is 2, y is 1, over 2 squared, which is 4, plus 2 times 1, which is 2. So that'd be negative 4 over 6, which is a negative 2/3. Okay. Now I'm going to do this one. So negative 2 times negative 2 times 1 over x squared, which would still be a 4. 2 times 1, which is still a 2. It's now a positive 4 over 6, which is a positive 2/3. So it looks like I'm getting positive and negative 2/3. Bingo. So the blue part is just differentiation, but the purple part helps you find the x values because it's implicit and it's got x's and y's. You need the x's that go with those y's. Okay, that was 33. So now we're going to Princeton 3, number 7. Princeton 3, number 7. Okay, it's not even implicit, like this is just x's. I just need the first derivative. So he must have some fun stuff going on. I'm going to think about this like this. Okay, here I go. Derivative, leave it, plus, leave it. Okay, now this is a turduck. So power, take 1 off your power, derivative of the inside. Okay, now I'm going to clean. This doesn't have anything. This does. I can clean all these little guys up, and that's going to give me 3 over 2x squared 3x plus 1 to the negative 1/2. Don't write him on the bottom because now look at this. Two islands. They both have a 3x plus 1, but they are different powers. Remember which one we're supposed to take out. It's always the smallest one, so it's going to be the negative. So I'm taking out the 3x plus 1 to the negative 1/2. Okay, when you GCF, it's like subtracting powers. Like if I have an x to the 5th and I take an x squared out, it leaves me with an x to the 3rd. So I'm subtracting. So I'm going to be left with a 2x. And then I've got my 3x plus 1. Now to figure out its power, I need to do 1/2 minus what I took out, a negative 1/2, which is a 1, which is wonderful. And then this is 3 over 2x squared, and then this was a 3x plus 1 to the negative 1/2, and that's what I took out, so I don't have anything left. Okay. So now I can distribute this, so that'd be 6x squared plus 2x plus 3 over 2x squared. All right, let's see how good y'all do with this stuff. These are like terms. I would hold off on that. Focus on the fact that he has a 2 on the bottom. So look, if I put a 2 on the bottom, that leaves that 3x squared here. I haven't done anything. But if I put a 2 on the bottom and I want this term right here to go here, this now has to become a 12x squared because that's a 6x squared. And then if I want to put this here, that's going to have to be a 4x because 4x over 2 gives me my 2. And then I can write this guy on the bottom with the 2. And then I can combine my like terms on top. We did that trick quite a few times. Again, I know it's been a while, but that's what we're doing. We're dusting off the cobwebs. All right, I'm headed to number 11. Okay, number 11, I want the derivative of tangent squared of 4x. And if you want to, you can think about it like that. Oh, wait, not to the 4th, sorry, to the 2nd. Okay, so I'm going to pull my power down, take 1 off my power, that would be a 1. But now I have to take the derivative of the inside. Okay, well, this is a full-on turducken. I've done the 2. Now I take the derivative of tangent, which is secant squared. That's my favorite one. But don't change your of, because that's the chicken. That's that last step. So let's see. I can multiply those two. Which is C. All right, now we're headed to 35. There it is. Okay, again, this is another one like one of those charts, and I'm just trying to, number one, expose you to these and make sure that you understand that these are not a big deal. It says h of x equals f of g of x, and I want h prime at a, so I just need to take the derivative of this. So outside, leave the inside, times the derivative of the inside. And I want to go at a, like they don't even give me an actual number. So I want f prime g of a, g prime of a. Okay, so I need to find g of a. G of a is C. Now what they have against actual numbers. And then I need g prime of a. G prime of a is right there, and that's a b, but just a plain old B, like it doesn't get plugged in into anything. Now I need this. I need f prime of c. F prime of c. Oh, there's a number, 6. So I have 6 times b, 6b. Done. It's like a puzzle. And it's really easy. Just follow your rules. Okay, so that's 35. So we are now done with Princeton. Now we're headed to the extra practice, and we're going to start with number 70. Extra practice number 70. Okay. It says sine of xy equals y, then dy dx. All right, we've got implicit. So here we go. Sine of xy equals y. And I want dy dx. Okay, here we go. Outside. Cosine xy times the derivative of the inside. That's a product rule. And remember, it's implicit. So I'm going to take the derivative, and then I'm going to leave it. Sorry, take the derivative, and then I'm going to leave it, and then plus, and then leave it, and then take the derivative of the y, which is 1, but it's a y. So dy dx. And then the derivative of y is 1, but it's a y. So dy dx. Okay, now now remember, this is not being ubbed. So what I'm going to do is I'm going to distribute my cosine of y to both of these guys because I need to be able to get my dy dx's together. So let's see. I'm going to put this y in the front. So y cosine xy plus x dy dx times cosine of xy equals dy dx. All right, now I'm going to take this term right here, which has my dy dx, and subtract them over. Okay, now I'm going to GCF my dy dx. That's going to leave me with 1 minus x cosine xy, and that equals this guy. And then I'm going to divide that over. So basically that's going to put this over there, which is D. Yep, D. Okay, that was 70. Now we're headed to 86. And 86, yet again, is another one of those charts which I hope are no longer weird. Okay, 86. P of x equals f of x over g of x, and I want p prime of 3. So first I have to take the derivative. So low d high minus high d low over low, and I want 3's. So I need g of 3. G of 3 is 2. Now I need f prime of 3. F prime of 3 is 2. Now I need f of 3. F of 3 is 4. And now I need g prime of 3, which is 3. And then I need just g of 3, and then I'm going to square it. G of 3 is 2. 2 squared. So this is 4 minus 12 over 4, negative 8 over 4, which is negative 2. And then I think for homework you get to do 87 and 88, so you get to practice finishing those as well. All right, very last one, number 90. And number 90 has to do with this chart, so we're going to write it down and then come back to the chart. It's the square root of f of x is r, and then I want r prime of 3. Okay, so I'm going to come back here and erase all this mess off my chart. Okay, it is r of x equals, that's the square root of f of x. I'm just going to go f to the 1/2. And I want r prime of 3. So I'm going to go turduck. I'm going to pull the power. And then that's to the negative 1/2. And then I take the derivative of the inside. And this is at 3. So I need 1/2. Now I need f of 3. F of 3 is a 4. And that's to the negative 1/2. And then I need f prime of 3, which is a 2. 4 to the negative 1/2 means square root me and move me to the bottom. So that's going to give me a 1/2. And then we come back here, and there he is. Okay, I don't think this stuff is crazy difficult. I do think you need to practice it, especially your ln's and your logs and your e to those and your 2 to those and your 5 to those. All of those you need to practice, and just let's get this stuff right, because this is very straightforward. Follow the rules, get it right. So practice makes perfect.